Okay, let's talk about the elimination method. So this is kind of going to be a review of what you probably did in algebra class in high school or maybe up here's college. And it's also going to be from a slightly different perspective. We're going to talk about a list of 3 different operations that you can do right here. To the system of equations that do not change the solution set, meaning they give you an equivalent system of equation. And one thing that you can do is you can take one of the equations and you can scale it, meaning multiply both sides of the equation by the same constant. So, for example, you might want to take this first equation and multiply both sides by -5, for example. And you could write what you're doing to keep track of your work by writing something like, we're going to take equation 1 and replace equation 1 with, let's say, -5 times equation 1. And that means we're doing -5 times the left side, which gives you -20x minus 10y, and also multiplying the right side by -5. And we're going to leave the second equation alone. And of course, if you had a value of x and y that made the original equation here true, then multiplying both sides by 5 doesn't change that, because if the left side was equal to -2, then if you multiply it by -5, you're going to get the equivalent thing here. You're still going to get 10 when you plug in that same x and y. So that works. And why would you want to do that? I don't know. Maybe you're a fan of the number -20 for some reason. Now, what's something else you can do is you can add both sides of one equation to another equation. And for reasons we'll explain in a second, this is called replacement. So you add a multiple of one equation to a second equation, replacing the second equation with the result. So, for example, one thing you might notice here is it would be nice if we could get rid of the x here. And you could do that because if you do 4 times 5, you'll get positive 20, and negative 20x plus 20x will cancel out to make 0. And that would give you an equation that only has y in it. So what that would look like is if we say, now I'm going to take this thing we have here, and I'm going to replace equation 1 with 4 times equation 2 plus equation 1. So we're going to take negative 20x plus 4 times 5x. That will give you 0x there. And then we'll have negative 10y plus 4 times 3y will make 2y. 10 plus 4 times -1 is 6. And we're still going to leave the second equation alone. Okay, let's talk a little bit about why this works, why it leaves you an equivalent equation. Maybe you haven't thought about it in a little while. Well, 4 times equation 2 here really means 20x plus 12y equals -4. And if you add both sides of this equation to both sides of this equation here, then we're assuming that we're talking about a value of x and y that makes this true. And in that case, then the left side is equal to -4. And we're really just adding -4 to both sides. So those are the first 2 things we're going to need to do. We're also going to have a third operation we can do to a system of equations. That's going to seem really pointless right now, but we'll see why it's useful a little bit later. you can swap the position of two equations. Just change the order that we're written in. For example, here we could just write that as equation 1 swapped with equation 2, which would give you the resulting system, like so, which is, of course, equivalent to this system right here. So let's actually continue solving this system of equations. The nice thing about why I chose negative 20 and 20 here for the coefficients of x to add together is because that gives you a 0x and you get this equation with just y in it. So then we can do another scaling operation. I'm going to take equation 2 and scale it by 1/2 to find y, which gives you 0x plus 1y equals 3. And of course, you don't really need to write the 0x, and you could just write y instead of 1y. But we'll see why it's useful to keep them here. So because in a minute, we're going to see how we can have a shorthand way of writing these equations. We're going to write it in the form of a matrix. And it's good to see that if there's a 0 here, that 0 is still going to show up in the matrix. Anyway, so now we've got basically y equals 3. Now to go back and find x, continuing just to do these 3 operations. And I know you can do it by substitution, like you can just replace the variable y here with 3. But we want to focus on the elimination method because that's going to be the most useful thing for the class later on. So to continue doing this with elimination, what we could do is multiply the second equation here by negative 3, so we got a negative 3y here, and then add that to the first equation. So this ends up being a replacement operation. We're going to replace equation 1 with the original equation 1 minus 3, or plus negative 3 times equation 2. And that results in 5x minus 3 times 0x is just going to be 5x plus 3y plus negative 3 times 1y gives you 0y. And then we have negative 1 minus 3 times 3 gives you negative 1 minus 9 is negative 10. And the second equation, I'm not changing here, so I get a still equivalent, a system that still has one system equivalent to each of the systems in the steps that we've done so far. And anyways, of course, then you can just do a scaling operation. I can do E1 will get scaled by 1 over 5. So that gives you 1/5 times 5x is just x, or 1 times x if you want to write that. 0 times 1/5 is still 0y equals negative 2, and we still have the second equation here is unchanged. So the solution of the system, and there's only one solution now because there's now that you really see that it's just x equals negative 2 and y equals 3. There's only one value of x and one value of y that clearly makes this work together. So that must be the solution set, is just the set containing that one number. Next, let's look at this harder example where we have 3 equations here with 3 variables. And what makes this harder is that you could do a row replacement operation, or sorry, just an equation replacement operation where we just add, let's say, equation 2 to equation 3, because that will give you a 2x1 and a negative 2x1 will add up to make 0x1, and that will get rid of the x1 variable there, and then you'll have an equation that has x2 and x3 in it. But then what do you do with that? It doesn't give you just a number. So then what we're going to have to do is then get a second equation that has x2 and x3 in it, and then deal with that system of those two equations together the way we did with the last example. So here's the result of the first couple of row operations, and I just combined 2 at a time so I didn't have to write out the whole system twice. So first, to clear out a 2x1 from this equation here, we want to turn that into a 0x1 by eliminating that. You can do negative 2 times equation 1 here, and that negative 2 times x1 plus 2x2 gives you a 0 there. And then we're doing the same thing to clear out negative 2x1 from the third equation. So if you do 2 times equation 1 plus equation 2 on both sides here, that's going to look like, well, I already did that first term there, but negative 2 times negative 5 plus negative 7 gives you 3. Negative 2 times 4 plus 3 gives you negative 8 plus 3 is negative 5. Negative 2 times negative 3 is positive 6 plus negative 2 gives you 4. And with the last one here, it should also all work out. So if you do 2x1 minus 2x2, that gives you 0. x1, did I just say x2? I meant x1. And then 2 times negative 5 plus 1 is negative 9. 2 times 4 plus 7 is 15. 2 times negative 3 plus negative 1 gives you negative 7. All right, so now we've got two equations here that both have the x1 eliminated from them. So what we can do now is, looking at this, say, okay, I now have, just looking at these two equations, let's just think about what can we do with just this stuff here. And what I would do is say, well, let's do 3 times 3x2 and add that to negative 9x2 to make 0x2. So that operation would be replacing equation 3. So it's a replacement operation with 3 times equation 2 plus equation 3. And that's going to give you the first two equations I'm going to leave unchanged here. And the third equation now is going to be still 0 plus 0, still 0x1. 9 plus negative 9 is now 0x2. And then let's see, oh, we're doing 3 times negative 5 plus 15. Oh, that's also 0. Okay. And let's see what happens here. 3 times 4 plus negative 7 comes out to be 12. So this system of equations now is only going to be true when this is equal to this, meaning 0 is equal to 12, which is impossible. It doesn't matter what the x1, x2, and x3 are. This is just false. So what that means is this system of equations here has no solution, and because this system of three equations is equivalent to this system of three equations, because we just did those basic operations, they have the same solution set. That means these also must also have no solution. So that is, whoops, the answer. Let's zoom back in there. All right, so here are your exercises to do now. This is part of your homework assignment for this video. So yeah, solve these using elimination. Try to show your work more or less. It doesn't have to be exactly the same way I'm writing things down, but try to write down the whole system of equations each time you do a step. And when you're done, check your answers by plugging your solutions into the original thing. And if you're having trouble with exercises like these in the videos, I'm going to try to mostly include basic exercises. And if you're having trouble with them, then definitely ask for help before class or during class or after class or something, because especially these ones are things it will definitely be important to be able to do. All right, so see you later.